Welcome to our AI-driven landing zone demo. Today, we'll show how AI can help you design and deploy OCI landing zones faster while keeping security at the foundation. The message is simple. AI does not replace guardrails. It helps apply them consistently from the very first decision. Before starting the demo, there are 5 pre-configuration steps. First, we select the AI coding agent that matches the organization's security and operational requirements. Then, we install and configure it using official documentation. Next, we install JSONet because it is required to generate the landing zone configuration. After that, we clone the OCI operating entities repository locally. And finally, we run the agent from inside that secured workspace, keeping source files and deployment artifacts under the organization's control. With this foundation in place, we can now guide the AI to define our custom landing zone. In this phase, AI helps translate our requirements into declarative landing zone configuration. We just described the intent. For example, I want a landing zone for OKE. The AI loads the repositories built-in landing zone skills to guide us through discovery and ask the right design questions. Before continuing, the AI shows a warning. The generated landing zone must always be reviewed for correctness, security, and compliance before deployment. We type, I accept, confirming that we understand the generated outputs must be reviewed before deployment. Here, the assistant guides us through discovery by asking which environments we need and which workloads the landing zone must support. Because the production environment is included, the assistant recommends a firewall-based hub and spoke design, so traffic can be inspected and controlled through a central security layer. The assistant presents the available firewall hub options and recommends Hub B, the simpler managed model with one OCI network firewall, which fits the required landing zone. This is the key point of the guidance. As we define the landing zone, security best practices are applied from the design phase, following the CIS recommendations built into the operating entity's landing zone framework. The next step is OKE network sizing. The assistant helps define the VCN, subnets, and Kubernetes CIDR ranges by asking about the expected number of clusters, worker nodes, and pods per environment. Next, the assistant checks external connectivity. This is important because CIDR ranges are hard to change later, and they must not overlap with on-premises or other cloud networks. The assistant then asks whether we already have an approved OCI address range or if it should propose one. Based on the answers, the assistant proposes a CIDR direction, reserving part of the approved OCI range for the hub network, allocating separate ranges for production, dev, and test OKE VCNs, and keeping Kubernetes service CIDRs outside both the OCI and on-premises ranges to avoid overlap. The assistant also highlights what remains manual after deployment. The landing zone can prepare the DRG routing foundation, but VPN service objects, tunnels, and routing settings still need to be handled separately unless they are explicitly supported by the generated artifacts. Before generating anything, the assistant asks where the source configuration and the generated landing zone outputs should be stored. This keeps the source files and deployment artifacts organized in the right workspace location. During artifact creation, The assistant reads the schema and OKE examples to stay aligned with the supported framework. It validates constraints like subnet sizing and node pool behavior, then creates the JSONed baseline with hub B and 3 OKE environments. It also flags an important limitation. Node pool sizing must be reviewed and customized downstream. Generation is now complete. The assistant checks the generated files and key, OKE, and network values to confirm that the expected cluster, worker, and hub B artifacts were created. It also records the main design decisions and the items that still require customer review, such as manual VPN setup and node pool sizing. At this point, the demo artifacts have been created. The source JSONed configuration, the generated landing zone outputs, and a README with the keynotes and review items. Now we ask the assistant how to review the generated landing zone and deploy it to OCI. The discovery and generation steps now give us a clear path to implement our custom OCI landing zone. The assistant provides two key outputs. First, it provides a pre-deployment checklist to review the design, generated files, OKE sizing, and key security controls. Then it shows the deployment path using the OCI landing zones orchestrator, which deploys landing zone configurations from JSON files. And this completes the demo, from guided discovery to secure landing zone design to generated artifacts and finally to a clear deployment path. The key takeaway is simple. The assistant helps accelerate the process while keeping security, review, and governance at the center of every step.